This video is just another example of finding the area inside of a polar curve. Now, I just want to remind you, because sometimes people forget this equation, and this equation is so important to being successful in Calc 2, that 1/2 the integral of r squared d theta. You know, you got to remember that. And remember, look back at the proof, the video, the proof on video, or look back at notes from class. But remember, this is really based on the area of a triangle, that we're fitting an infinite number of triangles, kind of a vertex at the origin, and they fan out to make the shape. That's where this is based on. So that's where that 1/2 is, because of course 1/2 base times height is the area of a triangle. Okay? So this should be, to start off with, it starts really easy. It's 1/2 and then r squared. And the tricky thing is always the bounds. Okay? So here's what we need to do. Okay? We know that this loop is what we want, and it begins and ends when r is 0. Okay, remember, r is how far away from the origin we are. So in the beginning and end of the loop, r is 0 because we're at the origin. So I take my equation and I set it equal to 0 because I need to figure out where r is 0. So I subtract 1. I divide by 3. And this is not one of those values that you need to know. You don't know the cosine is negative 1/3, or the cosine of theta is negative 1/3. So you're going to actually use the inverse trig function on your calculator to figure out what theta is. When I type that into my calculator, I get a 1.911 radians would give me, when I plug that into cosine, would give me negative 1/3. And what I would recommend to you is, with your calculator, maybe graphing this original equation and changing your window. You know, start it at 1.911 instead of theta, and you'll see that that starts it right here. You won't see this beginning of the loop. You know, you won't see this piece that I'm pointing at right now. It will start right here and begin drawing like that. Now the question is, because it's going to continue, the question is, how do we cut out this? Well, the easy way to do that is to say that, you know, think about the unit circle, that 1.91 is somewhere over here in the second quadrant, because that's where cosine is negative. The other spot cosine is negative is in the third quadrant. So I could go 1.91 units from 0, or I could go 1.91 units back from 2 pi. So my top bound is 2 pi minus 1.911 units. And again, I would absolutely graph that. You know, go to your calculator, graph it, and what you'll see is that your bound, those bounds, 1.911 and 2 pi minus 1.911, just trace that inner loop. And then you put that into FNInt on your calculator, and you've got it.